Hello everyone. So in the previous class, I have explained you about architecture of LSTM. So the three gates which I told, forget gate, input gate, and output gate, we have seen in the architecture. How they work, what are the equations of these gates, we have seen in the architecture. And I told that LSTM is an advanced version of RNN, and LSTM do improve the disadvantages of RNN. Major issue was vanishing gradient problem that was overcome by LSTM, and LSTM is better in the way that it do capture long term and short term dependencies. Yesterday also I told long term and short term what they mean. Dependencies, term, what do you mean by term? Term is a word in a sequence. So you are giving data here in form of a sequence. The cat sat on the mat. Okay, this is a sequence. The cat sat on the mat. So the and cat, these are short term dependency. Okay, here my model is learning what could be a next word after the. So the more important thing in text analysis is, which we haven't got in machine learning simple ML algorithms, is context and sequential data interpretation, because machine learning models like simple classifiers, logistic, decision tree, random forest, naive, they don't consider your text as sequence, neither they do talk about the context. But here, with RNN, recurrent neural network, and the updated versions of RNN like LSTM, we are interpreting sequential data, we are trying to identify the context. So short term dependencies are important as they are recent, they are new, and they are closer. So it helps me what word could be the next word in a sequence. I can have a prediction by learning them. However, long term dependency, for example, I write a sentence: the cat I saw at the park yesterday was very friendly. Okay. And I need to identify the dependency between cat and was. This is long term dependency. You can see in a sequence, these two words are very far away from each other. Okay. However, as I divide this text into sequences, the cat I saw at the park, Let us suppose this is sequence number 1. Okay. Then yesterday was very friendly, sequence number 2. So as we keep on adding the sequences, it becomes very much difficult for a term in a sequence to have a correlation with another term in a sequence. That's what I call as a long term dependency. However, LSTM has a capability to take a note of long term dependency. And I also told yesterday that long term dependencies are handled by cell state in LSTM, and short term dependencies are handled by hidden state in LSTM. It is very much mandatory to watch the recordings which I do share. I have also shared the notes, handwritten notes. I am doing the effort for you. Okay, 10 pages handwritten. I did shared the entire notes of LSTM, also of RNN. It is mandatory for you to go through them. Okay. So cell state manage long-term dependency, hidden state manage short-term dependency. Remember one thing, length of both these are vectors. Length of these two vectors are same. Obviously, they will become a vector now. You very well know what is the way to interpret a text. Yesterday also I told in the class that first you have to tokenize, then you have to convert into numerical representation, that is integer. Okay, integer. Every token you have to assign an integer value. Then you have to find the sequence. Then you have to perform the padding. Then you have to perform embedding. After all these things, do try what we are studying right now. After all these things, you are having the sequence, proper length. Okay, however, LSTM has an ability to handle variable length sequence also. No worries with that. But this is in general what we have learned in RNN also. Okay, so you have to follow this approach and then deal with that your whatever you are getting. So this will be now a vector. Okay, so we are having cell state and hidden state, both are the vectors. And if I again check the architecture, the maths which are used in the architecture, which is very much important. So in architecture, first we deal with forget gate. Why forget? Because the reason is, sir, as the sequence keep on increasing, it is not mandatory to store each and every information, because we have seen this issue in RNN and in back propagation during gradient calculation. When they got multiply, they can vanish. It can vanish the entire, it tends to zero. So sir, kindly do one thing. What are the short term dependencies you do care, long term dependencies kindly be selective. We did not have to remember each and everything what happened in the past. Only selective things we have to remember. That is performed by your forget gate. Okay, and you know this component how I added in the architecture. This is your CTL. t minus 1, that means previous cell state. This is your previous hidden state, ht minus 1. Both are the memory. ये भी मेमोरी है, ये भी है, स्टोर कर रही है ना, ये बड़ी डिपेंडेंसी को स्टोर कर रही है। इसमें भी क्या है, वेक्टर है, वो वर्ड्स के वेक्टर रिप्रेजेंटेशन है इसमें भी। ओके, ये एक वेक्टर है, इसमें यहां न्यूमेरिकल वैल्यू लिखी है। दिस इज ऑल्सो अ वेक्टर, हियर ऑल्सो न्यूमेरिकल वैल्यूज आर रिटन। वर्ड्स को न्यूमेरिक में कन्वर्ट करा ना, फिर ही तो आगे काम कर रहे हो तुम। ओके, एंड xt एन इनपुट इज गिवन। ठीक है, तो यहां से ht आया, यहां से xt आया, एंड इनको कॉन्कैटिनेट करा, एंड आई गेव इट टू अ लेयर। ठीक है, वेर यहां सिग्मोइड एक्टिवेशन फंक्शन है, एंड द रिजल्ट विच यू गॉट, you gave here for the multiplication with ct minus 1, and this is the result which you are getting from the forget gate। तो इतना जो है ये forget gate है। okay, so short term dependency, new information, perform sigmoid whose value will come between 0 to 1। ओके, अभी आपको जो यहां पर आउटपुट मिलेगा वो 0 से 1 के बीच में मिलेगा यहां पर, एंड व्हेन यू मल्टीप्लाई इट विथ ct minus 1, that will be the output which you will get। तो इसमें आपकी पुरानी जो बातें हैं, लॉन्ग टर्म डिपेंडेंसीज हैं, द वन विच आर रेलेवेंट, बस उसी को रखेंगे, बाकी को लीव, ये करेंगे। अब इसमें थोड़ा सा ध्यान दो आप। इसका मुझे मैथ्स बतानी है। लेट अस सपोज ht1 जो है, हिडन स्टेट जो है, ओके, लेट मी डू हियर ओनली ht minus 1, इसकी लेंथ है 3, xt द इनपुट, इसकी लेंथ है 4, टोटल लेंथ हो गई है 7। I hope if you remember the equation which I have written in the previous class. What equation I wrote? I mentioned that W, that is the weight matrix of forget gate, and ht minus 1 comma xt. So here I am concatenating hidden state and the input. That's what I am doing. Multiplying with the weight of the forget gate plus bf, that is the bias term. The result which I am getting overall, I have to give it to the sigmoid function, this one। Here is the equation। तो ये इक्वेशन थी, कल आपको बता दी मैंने इक्वेशन। ओके, सो राइट नाउ we are having ht minus 1, this is having a length 3 है। ओके, केस लेकर चल रहा हूं, xt 4 है, तो टोटल हो गया 7। तो ओवरऑल जो इनपुट है, ये जो इनपुट है ये है 7 क्रॉस 1 का। ओके, दिस इनपुट इज ऑफ 7 क्रॉस 1। अब यदि इसे वेट से मल्टीप्लाई होना है, इफ आई नीड टू मल्टीप्लाई दिस थिंग विद अ वेट, तो मैट्रिक्स अब जो मल्टीप्लीकेशन होगा उसको ध्यान देना पड़ेगा। वो ऐसा होगा, वेट को मैं ले रहा हूं 3 क्रॉस 7, क्योंकि अनलेस एंड अंटिल यू वेरी वेल नो ये दोनों सेम नहीं होते ना, तब तक मैट्रिक्स मल्टीप्लीकेशन परफॉर्म नहीं होगा। You can't multiply the two metrics unless and until these two are not same. ओके, तो भाई ऐसा जो है हमने बनाया। और थ्री भी क्यों लिया, आप क्वेश्चन कर सकते हो कि सर आपने 3x7 ही क्यों लिया, 4x7 ले लेते आप। कारण है, आई वॉन्ट हियर एज अ रिजल्ट ऑफ 3x1, मुझे ये रिजल्ट चाहिए 3x1 का। क्यों चाहिए? Because you very well know that whatever be the result which I am going to obtain here, I need to perform point wise operation जो कि है multiplication, ये multiplication है, उसको मुझे CT-1 के साथ point wise multiplication करना है। And just I told you कि whatever be the dimension of ht-1, same dimension will be of ct-1, है ना। जो लेंथ ht-1 का है वही ct-1 का होगा। तो ht-1 3 का है, तो ct-1 भी 3 का ही होगा। और इफ आई नीड टू परफॉर्म द मल्टीप्लीकेशन, तो भाई जब ct-1 3 का आ रहा है, तो वट एवर बी द आउटकम आई रिक्वायर हियर वो भी 3 का होना चाहिए। तो यही एक कारण बना, दैट इज वन ऑफ द रीजन that I do have the weight matrix of 3x7। हर एक चीज के पीछे मैथ्स लगी है, हर एक चीज के पीछे लॉजिक लगा गया है, सोचना पड़ेगा। टफ नहीं है, तभी तो मैं आपको समझा रहा हूं, आपको थोड़ी ना स्ट्रेस देना, मैं हूं तो सही। ओके, सो नाउ लेट मी शेयर माई एंटायर स्क्रीन and listen carefully each and everything. Here, weight and the hidden state, they both are combined. So not weight, that is the input and the hidden state. Okay, both are combined. So like I took them थ्री, ये हिडन स्टेट के हैं, 1 2 3 4, तो ओवरऑल 7 डॉट्स हो गए, 7 इनपुट हो गए, ये 7 इनपुट हैं, 3 from ht-1 and 4 from xt। Here I will take 3 sigma. Why 3 sigma? Because I require 3 outputs. That will be f1, f2, f3. So I will make a vector of these three like this: f1, f2, f3। That will be, यदि मैं इसको रो वाइज बना दूं तो कोई इशू नहीं है, ये रो वाइज भी आप कंसिडर कर सकते हो। Okay, you can consider it as a row wise f1, f2, f3। So it will be like 3x1, जिसको आगे जाके मैं बोलूंगा f, ये बोलूंगा मैं आगे जाके, ठीक। So I am having 7 as an input, and that I will give to each and every layer। Okay, each and every layer। Okay, you can give this to each and every neuron present in a layer, ये दे सकते हैं आप। And same thing here also, इसको भी all will be given to this sigmoid। ओके, ये सब देना पड़ेगा आपको, और ये आखिरी वाले के साथ भी सेम एज इट इज। ओके, सो व्हेन द वेट गेट्स, अच्छा तो हाउ मेनी वेट्स आर देयर? द शेप ऑफ वेट इज 3x7। ओके, सो देयर आर 21 वेट्स। ओके, देयर आर 21 वेट्स प्रेजेंट। अब देखो ना, ये 3 हैं, ये 7 हैं, सो फ्रॉम एवरी टू एवरी जाता है। डीप लर्निंग आई ऑलरेडी एक्सप्लेन यू, तो एवरी टू एवरी जा रहा है, तो 3 7 21 कॉम्बिनेशन बन रहे हैं, सो 21 वेट्स होंगे। ओके, देयरफॉर अच्छा 21 वेट्स हो गए। बायस टर्म कितनी है, हाउ मेनी बायस? बायस आपकी रहेगी, ओके, व्हेन यू डू परफॉर्म WX प्लस बी, तो वेट्स भले ही आप कर दो, बायस टर्म तो देखिए, इसका हम B1 ले सकते हैं, इसका हम B2 ले सकते हैं, इसका हम B3 ले सकते हैं, तो वी आर हैविंग 3 बायस। ओके, सो in general, the equation for the deep learning is written like this: summation of wi xi plus b, ये लिखी जाती है deep learning की equation. Okay, so here, whatever be the inputs you are going to give to this layer, sigmoid है यहाँ पे. All right, so each and every, this one, then this one, so you can write w11, w12, w13, w14, w15, ये कर सकते हो. Okay, so all seven मल्टीप्लाई बाय इनपुट. इनपुट क्या है आपका? दैट इज एच टी माइनस वन कॉमा एक्स टी, ये इनपुट है. और बायस ऐड कर दो साथ में, बी वन कर दो, तो ये काम हो जाएगा. दूसरे वाले का, फॉर द नेक्स्ट वन इट इज बी टू एंड द नेक्स्ट वन इट इज बी थ्री. ओके, फाइन. And you are getting here as 3 cross 1 as a matrix whom I am calling it as ft. Okay, so total number of weights are 21, total number of bias are 3, input is 7, output you are getting 3 cross 1, length of 3 आपको मिल रहा है आउटपुट पे, ये वेक्टर मिल रहा है. ओके, तो अभी ये ऑपरेशन परफॉर्म हुआ. दिस इज द ऑपरेशन विच हैज बीन परफॉर्म. ओके, विच वन? ओके, हियर, फाइन. दिस ऑपरेशन is performed, ये वाला, and you are getting the output between 0 to 1. Now I need to perform point-wise multiplication with ct minus 1. Okay, so that's what you can do. ct minus 1 वो भी 3 cross 1 का ही है, and point-wise करना है आपको. So ct minus 1, ct minus 1 point-wise multiplication with ft. Okay, so the result which you are going to get here is, that will be 3 cross 1 again of length 3, 3 cross 1 का मिलेगा. एंड पॉइंट वाइज ऑपरेशन होगा. और यहाँ पर जो बातें भूलने की है पुरानी लॉन्ग टर्म डिपेंडेंसीज की, वो काम हो जाएगा. द लॉन्ग टर्म डिपेंडेंसीज विच आई वांट टू फॉरगेट, दे कैन बी फॉरगेटेड बाय मल्टीप्लीकेशन विद द एफ टी. ओके, फाइन, ये जो है आपको मिल जाएगा. ओके, कैसे? फॉर एग्जाम्पल, इफ एफ टी, इसका भी मैं एग्जाम्पल देना चाहूंगा. इफ एफ टी केम टू बी 0 0 0, फॉर एग्जाम्पल ये आपका जो एफ टी आया है ये 0 0 0 आया. एंड इफ यू मल्टीप्लाई इट विथ पॉइंट वाइज मल्टीप्लीकेशन, यदि सी टी माइनस वन के साथ करोगे. ओके, लेट अस सपोज सी टी माइनस वन इज लाइक, you can have 0.5, 0.2, 0.1. This is ct minus 1. You have to do point-wise multiplication. So 0 into 0.5, 0. 0 into 0.2, 0. 0 into 0.1, 0. All answer are 0. That means nothing to remember. Forget everything. Forget everything which is present in ct minus 1. जो हमारी लॉन्ग टर्म डिपेंडेंसीज है उसमें कुछ भी याद नहीं रखना है. क्यों? क्योंकि आपका एफ टी माइनस वन ये आया. In case if you are having ft minus 1 like 1 1 1, and if you multiply by ct minus 1, okay, now everything will be remembered, क्योंकि आप जानते हो 1 से मल्टीप्लाई करोगे तो वो सेम की सेम आ जाएगा. सो हियर एवरीथिंग विल बी रिमेंबर्ड. ओके, अब इन केस यदि आपके पास एफ टी आता है 0.5, 0.5, 0.3, और ये बात याद रखिएगा कि एफ टी का वैल्यू 0 से 1 के बीच में ही आएगा. Why? Because you have applied a sigmoid activation function. Okay, and sigmoid lies between 0 to 1 only. Okay, so if ft comes like this 0.5, 0.5, 0.3, and if you multiply by ct minus 1, then neither all the information will be captured, neither everything will be forgotten. There is some information. There is some information I will keep. Okay, I will keep. Okay. So आप ये समझे कि लॉन्ग टर्म डिपेंडेंसीज में यही तो आपसे बोला गया ना, फॉरगेट को अब आप प्रैक्टिकली समझ रहे हो एग्जाम्पल देख के। फॉरगेट गेट का द यूटिलिटी, नाउ यू आर able to understand that it told not everything is important for us. So how mathematically you will solve that everything is not important? This is a way. You first calculate ft and then perform pointwise multiplication by ct minus 1. Okay, so short term dependencies I am keeping, but long term dependencies I am being selective. Short term, the context is very much important because word to the next word that is being considered. But long term, I just told you an example of cat, park. Okay, so the words which are very far away from each other, and if I'm saying that okay, this is important or not important, what's the consideration? Okay, so for that now I have to check out this maths. So this is the work of forget gate. Only one component you have solved so far. That means you got a result in form of ft multiply pointwise multiplication ct minus 1. This is the output you got from forget gate. Okay, so forget gate allows LSTM to selectively forget irrelevant information. Okay, something which I don't want to carry on, just forget it. Solving problem of vanishing gradient descent. Okay, this maths, the operation which you have done, it will solve the problem of vanishing gradient descent. Okay, and long term dependencies may not give context information. Why you are applying this operation over context information? Long term dependency. Why only this? Because it may happen that I am not getting any context information between cat and was. Cat and was are very far away. That means these terms are very far away from each other. I'm not getting any information from it. How cat and was are related to each other? If they are not related, then drop it. Why you are keeping this thing? So that is how it solved a problem of vanishing gradient. Okay, but remember one thing: short-term dependencies we are not forgetting. Short-term dependencies means these are recent information, and on recent information we have to consider the context. Okay, so it will not be forgotten. The one which happened recently, we are not going to forget it. The one which happened so long that we can forget only the important terms of those which happened long way back, that has been considered. Okay, after that, after the forget, what you got from here, now it comes input gate. Okay, and input gate there are two operations. Okay, one is your gathering information, gathering information. One is filtering information. These two operations has been performed in input gate. Okay, and gathering information is just like same as we have seen in the forget gate. Okay, it's like h t minus 1 comma xt. Okay, and then w. This is input na, input gate. So wi, the weight has been changed. It is wi plus bi, bias. Okay, give it to the sigmoid activation function. Okay, fine. So here I am getting the answer as it, input gate. So all these things are just like forget gate only. Okay, so gathering information. Next one is filtering information. Okay, that will do. So according to the architecture, what we are doing after forget gate, okay, you again give ht minus 1 xt as an input. It goes given to the sigmoid, you got something. That is IT. Okay, you get the output as IT. And okay, this is your IT. Output you will get. And again, you follow up this HT minus 1. Okay, along with XT, you again follow up XT. And the next operation is hyperbolic tangent, 10H. Okay, this is what you do, 10H. Okay, and you do perform here pointwise multiplication of these two results. And then you tap it again back to the main line from where the results of forget gate is coming. That means this thing, ft into ct minus 1, which is coming, ft into ct minus 1 is coming. You tap it here. This is what happens at the input gate. Okay, so this operation, the first one, gathering, getting it, this is as similar as forget. In the next one, the only changes, you are applying hyperbolic tangent instead of sigmoid. Okay, what you are doing again, if I do consider, so this is the first equation in the input gate, and this is the second equation in the input gate, 10H W. Okay, 10H, and here you can write the same thing, W. Okay, input. Okay, and then you can have HT minus 1 XT plus BI. Here you are applying hyperbolic tangent activation function. Okay, so it can be drawn in this way: 1, 2, 3, 4, 5, 6, 7. Again, 3 HT minus 1, 4 XT, total 7. So 7 I have taken here. Okay, and then after taking 7, take 3 10H, hyperbolic 10H, hyperbolic 10H, hyperbolic 10H, and again every to every connection. Okay, every to every connection. Same here also with this one also, just like as you did with the sigmoid now. So every to every connection. The result which you will get from here is C1, C2, C3. That will again be converted into C1, C2, C3. That will be 3 cross 1. Either you can make it like this, C1, C2, C3. Okay, that is called as CT tilted or dash. This is candidate cell state. This is called as candidate cell state. Candidate cell state means temporary. Candidate means temporary update. Okay, this is temporary update in the cell state. That means I want to add new information. I added a new information in the network. Okay, new information is added in the network. But right now it is temporary. Okay, because unless and until I will not operate with this CT. Okay, from here I got CT now. Here I got CT. Here I got IT. So IT pointwise multiplication with CT candidate. This will be the answer which I'm going to get Let us suppose C dash T. This is the answer I will get after performing pointwise multiplication. But that's not the final answer. That is not the final cell state I'm getting. I need to add this also to this. Then only I will be getting the final answer. Okay. So the one which you got, C dash T, that is candidate cell state. Okay, that is temporary memory. Okay, that is temporary memory. Okay, it consists of new information. Okay, it consists of new information. Okay, I'm applying what I took hidden ht minus 1, I took xt, weight, and the bias, and I applied 10h. So hyperbolic tangent, you very well know, it normalizes the value between plus 1 to minus 1. So here, new information. It is not sigmoid. Okay, sigmoid is a classification. Minus 1 to plus 1, that means it is normalizing the value between this range. So I am having potential new information. So in this, new information is there. Okay, so it consists of new information that can be added to the cell state. Okay, but the final update will be when I am going to have the older information also. Okay, okay. So here I got candidate cell state. I multiply it with IT into this thing. Okay, so IT into this thing plus the one which is coming from the forget gate, that is FT into CT minus 1. So the selection from previous long term dependency and new information. This is new info. This is old info. So new info and the old info, it will be updated info. Okay, this is updated information. This information will be kept in a cell state. This is CT. तो पुरानी वाली जो जानकारी है वो और नई वाली जो जानकारी है वो दोनों को मिलाना है आपको. यू हैव टू ऐड अप दीज टू. ओके, तो यहां से हमने सिलेक्ट कर लिया कि पुरानी कौन सी रखनी है और ये न्यू इंफॉर्मेशन है. ऑल राइट, सो न्यू एंड ओल्ड विल बी एडेड एंड दिस विल अपडेट द सेल स्टेट CT. ऑल राइट, तो यदि मैं कंक्लूड करना चाहूं इनपुट गेट की वर्किंग. ओके, इनपुट गेट. तो इनपुट गेट हेल्प करता है. इट हेल्प्स in deciding how much new information should be added. Okay, how much new information is added. देखिए, मैंने सिर्फ CT नहीं लिया, ये तो न्यू इंफॉर्मेशन थी, बट इसको मैंने मल्टीप्लाई करा IT से. IT से मल्टीप्लाई होने के बाद ही ये क्लियर होगा हाउ मच न्यू इंफॉर्मेशन. हाउ मच, इट डजंट मीन दैट एवरीथिंग इन द न्यू इंफॉर्मेशन इज एडेड. नहीं, ऐसा नहीं. IT से मल्टीप्लाई होने के बाद ही जो आंसर आया वो ही बता रहा है हाउ मच न्यू इन्फॉर्मेशन शुड बी एडेड. सो यहां से न्यू इन्फॉर्मेशन का आइडिया लग रहा है कितनी होगी. एंड प्रीवियस तो आ ही रही थी पीछे से. ओके, प्रीवियस वो फॉरगेट गेट से तो आ ही रही थी. ओके, दैट इज FT इंटू CT माइनस 1. सो प्रीवियस में कौन सी रखनी है, नई में कौन सी रखनी है, दोनों को ऐड करो. सो दैट विल बी CT. That will be the new current state. Okay, so input gate regulates new information. It combines with the candidate cell state. Okay, it also give the updates. तो ये updated CT है, ठीक है. And obviously it is meant for learning and adaptation. Okay, learning and adaptation. Okay, that's what happening here. in the input gate. Very important. So from here you got an idea what input gate do. Okay, and then last comes the output gate. तो cell state तो मुझे मिल गया. Cell state I can give it finally CT ये गया. The last one is the output gate. अच्छा उसमें भी यही काम होगा पहले. एच टी माइनस वन ये रहेगा, एक्स टी रहेगा. ओके, so this is one of the operation it will follow and given by the sigmoid रहेगा. तो this two will be given to the sigmoid. Okay, and एक आउटपुट मिलेगा आपको. Okay, you will get an output that is called as OT. Okay, there will be an output called as OT. एंड जो आउटपुट मिलेगा आपको OT, ये जो CT है इसको टैप करना है नीचे 10H के साथ. एंड OT and 10H of CT, we have to perform point wise multiplication of them. That will be your final HT. Okay, that will be your final hidden state. Okay, so let me rewrite what are the operations. So in output gate, again you are doing the same thing, that is HT minus 1 and XT. ये W तो था ही, W आउटपुट वाला प्लस B0 बायस आउटपुट वाला. And here you have to give it to the sigmoid. So the answer is OT. डायमेंशंस आपको सबके पता है. ठीक है, ये 21 वेट्स हो जाएगा, ये 3 का है, ये 7 का है, ये 3 का है. ओके, तो सेम थिंग ना यू कैन फॉलो. डायमेंशन सबके पता है, सब वेक्टर्स हैं. दीज ऑल आर वेक्टर्स, वेट की मैट्रिक्स है तो वेक्टर्स एंड मैट्रिक्स. ओके, एंड यू गॉट ओटी. ओटी आप जानते ही वही 3x1 का ही मिलेगा. और चलो ये मिल गया, और पीछे से आ रहा है सीटी इनपुट गेट से, तो इसको आगे तो बढ़ा ही दोगे. यू विल फॉरवर्ड सीटी, लेकिन इसकी टैपिंग और करोगे. इसको आप 10H में दोगे सीटी को. ऑलराइट, ये काम करोगे, इसको 10H में दोगे. सो 10H सीटी ये आपको करना है. एंड वट एवर विद द रिजल्ट यू आर गोइंग टू गेट फ्रॉम हियर, वो मिलेगा, वो 3x1 वाला ही मिलेगा. ठीक है, और अच्छा ये भी क्यों करा, वाई वी डिड दिस थिंग. ये आपको आउटपुट मिल गया था ना, तो ये जो आपको आउटपुट मिला ओटी, ये तो एंटायर है, पूरा है ये एस टी एक्स टी और ये तो पूरा है. ठीक है, ओटी आपको इसे मल्टीप्लाई करना है 10H ऑफ सी से. ओटी को 10H ऑफ सी से मल्टीप्लाई करना है. ये आपको दे रहा है एच टी, दिस विल गिव एच टी. So here the output gate control how much CT should be passed to HT. Okay, that means how much long-term dependency should be given to HT. So HT is used for, because HT is used for further computation. Further computation. Okay, so the output gate ensures only relevant information should be available for subsequent computations. ये इंश्योर करता है, आपको एच टी इंश्योर करना है, क्योंकि आगे फिर आप नेक्स्ट सेल बना लोगे. ठीक है, अब ये तो कंटिन्यू होगा, इतना कंपोनेंट खत्म हुआ फिर दूसरा कंपोनेंट लग जाएगा, फिर थर्ड कंपोनेंट विल बी एडेड. ओके, सो राइट नाउ यू हैव सॉल्व्ड ओनली वन, दिस सेल एच टी माइनस वन, sorry ct minus 1, ht minus 1. Here you are getting ct and here you are getting ht. Now the next one will be ct plus 1, ht plus 1. दिस इज CT+2, HT+2। तो ये सब्सिक्वेंट में आप ये जानते हो HT का बड़ा मेजर रोल है, क्योंकि आपकी शुरुआत ही इसी से होगी, HT से और XT से हो जाएगी फिर, और वेट से मल्टीप्लाई करोगे और बायस ऐड कर दोगे। ऑल राइट, सो ये जो HT आया, द ऑपरेशन विच यू हैव परफॉर्म्ड, व्हाट, OT, पॉइंट वाइज मल्टीप्लीकेशन विद हाइपरबोलिक टेंजेंट ऑफ CT, ये आया HT। ओके, अगेन द साइज इज 3x1 ओनली, साइज चेंज थोड़ी ना होगा, साइज 3x1 ही। सो आउटपुट गेट ने क्या करा, इट कंट्रोल हाउ मच CT, कितना CT देना है, how much CT should be given, okay, so that I'm going to get a hidden state, how much CT should be passed to HT, so that HT will be, hidden state will be further used in the next computations। ठीक है, तो आउटपुट गेट इंश्योर करता है रेलेवेंट इंफॉर्मेशन ही जानी चाहिए। तो अभी तक हमने रेलेवेंट इंफॉर्मेशन की बात करी है। RNN में वी हैवंट थॉट ऑफ रेलेवेंट इंफॉर्मेशन एंड व्हाट टू फॉरगेट, व्हाट टू रिमेंबर ना, we haven't talked anything related to this thing, relevancy in RNN, but in case of LSTM we are talking about relevancy. So that's the reason we use three components: forget, input and the output. Now from output you are getting this hidden state HT, okay, also CT जो चल रहा था वो तो चलेगा ही चलेगा, ये लॉन्ग टर्म डिपेंडेंसी है, शॉर्ट टर्म डिपेंडेंसी है HT, एंड अगेन वी विल स्टार्ट अप, ये वापस से इसको वापस लगा देंगे, ये काम कंटिन्यू करते रहेंगे। This is the architecture working equations of LSTM. I hope you learned this thing. And why LSTM are important? What is the reason? Because I just told you LSTM वो long term and short term दोनों को ध्यान रखता है, खास करके long term। ओके, वैनिशिंग ग्रेडियंट डिसेंट अवॉइड करता है, क्योंकि रेलेवेंट इंफॉर्मेशन ही आगे जाएगी, नॉट एवरीथिंग। तो वैनिशिंग ग्रेडियंट डिसेंट को हम उस प्रॉब्लम को देखेंगे। सिलेक्टिव मेमोरी है, सिलेक्टिव अपडेट करता है, सिलेक्टिव मेमोरी अपडेट। ओके, इट कैन हैंडल वेरिएबल लेंथ सीक्वेंसेस आल्सो, नो वरी। You can use LSTM in time series problem also and in text also, that means sequential data, ये दोनों में आप LSTM का यूज कर सकते हैं। It has a capability of bidirectional, इट कांट, इट्स नॉट ओनली कि सर ये सीक्वेंस को लेफ्ट टू राइट इंटरप्रेट कर रहा है, नहीं, ये राइट टू लेफ्ट भी कर सकता है इंटरप्रेट सीक्वेंस को, ये इसकी खासियत है। सो वी डू हैव अनदर आर्किटेक्चर दैट इज कॉल्ड एज बाई LSTM, आगे समय रहने पर देखेंगे। सो इट इज बाई डायरेक्शनल इन नेचर, इसकी कैपेबिलिटी है ये इसके एडवांटेजेस हैं LSTM के। देर आर सर्टेन डिसएडवांटेजेस ऑल्सो ऑफ LSTM, दैट मीन्स थोड़ा सा कॉम्प्लेक्स है। ओके, इट माइट बी ए कॉम्प्लेक्स इन नेचर, स्लो ट्रेनिंग परफॉर्म होती है, स्लो ट्रेनिंग, तो GPU लगा लो तो ठीक ठाक रहेगा। ओके, कॉम्प्लेक्स इन नेचर, स्लो ट्रेनिंग, मेमोरी रिक्वायरमेंट हाई रहेगी, तभी मैंने बोला GPU लगा लो, हाई मेमोरी है ना। ये सिंपल डीप लर्निंग वाला हिसाब किताब नहीं है, आप देख रहे हैं कि काम थोड़ा सा बढ़ गया है, 3 गेट्स हो गए ना अब, तो ऑपरेशन बढ़ गए ना अब। सो ऑपरेशन बढ़ गए तो कॉम्प्लेक्सिटी बढ़ गई, ट्रेनिंग स्लो हो रही है, मेमोरी ज्यादा लग रही है। Still there is an issue in difficulty, there will be a difficulty in learning long sequences, ठीक है। Still there is an issue in learning the long sequences, overfitting भी हो सकता है यहाँ पे, it may face a problem of overfitting। So these are certain issues in LSTM, and these are something good ones in LSTM, advantage and disadvantage। Okay, so this is about LSTM, the entire concept, and in the next session I'm going to implement LSTM. I will be writing the code for LSTM to predict the next word in a sequence using LSTM. Okay. So I hope you enjoyed the class. We did learn a lot of things here.